Hi, welcome to the recording for the FBF point 3 for Unit 1, the standard that has to do with transformations. This test that it comes from, the Module 1 test, was split into 3 different standards that we could test, had enough questions on it. So this standard specifically has to do with transformations as transformations. So that means moving it up, left, right, down, back, stretching it, whatever. But what specifically we're going to be talking about today is in regards to, so it's transformations and specifically in regard to exponential graphs. That's what this main standard is on for this thing. In order to talk about transformations, you first have to understand what a parent function is. A parent function is a function that is the basic function. And then you can move it up, down, left, right, stretch it, flip it, whatever, like reflect it, whatever you need to do, like whatever needs to happen. But we start with the parent function. So if we looked at the parent function of this graph, so I went to Desmos, it's my favorite graphing calculator, and we graphed it, we'd get this point right here. So you can see it crosses the y-axis right there. This technically would mean it would never cross the x-axis. And we could see that there's other points that coordinate with things. Like if you got 2 to the power of 2 would be 4. If we did 2 to the power of 3, that would be up here at 8. Well, if I can get it to work, but I can't. Okay. Anyway, so this is the parent function, and everything else that we do from there is just shifting it. So let's draw that parent function. It goes like here, like this. So it crosses right there at the point 0, 1. But if we were to switch this up a little bit, I just wanted to show you the difference. If instead of doing 2, if we did 1/2, let me back this up, 1/2 to the power of x, notice that it flips it the other way. That. And it basically would have very similar points. So it's going to start bigger and go smaller. And everything else from there that we do is doing something to that. So I have a couple examples here. We're going to either add 3 to the whole problem, add 3 to only the exponent. We're going to multiply it by 3 in the front, multiply it by 1/3 in the front, multiply just the x by 3, and that was supposed to be a 3 right there, and 2 to the 1/3 right there. We're just going to look at a bunch of different things. So let's start with just plain 2 to the x, because that was our main parent function that we started with. Yep, 2 to the x. X. Well, it's not cooperating, is it? To the x. Okay, so here's our parent function, right? And I'm going to keep it there, and I'm going to call the next one then the rest of everything that we're going to do. So if we had 2 to the x, and then we added 3 to it, you can see that the only thing that we did here, let me zoom out, all we did, whoa, that zoomed out really funny. All it did was it moved it up 3. So instead of crossing right there at 1, it crossed up at 4, right? There, 4. So adding 3 at the end, that moves it. We can summarize this. If we did adding at the end, this is going to move it up or down. So if we subtracted 3, that would move it just down 3. Then let's go back and try adding 3 to just the x, not to the whole thing. Plus 3. Now it's going to have a hard time with everything. We're going to do parentheses and then plus 3. So that made it like more intense. So if we did, so this would be like saying instead of 2 to the power of 0 is what it would be at first. This is saying 2 to the power of 3 at the very beginning. So that would cross at 8. It just makes it stretch. So that right there, it would, makes it more intense. Makes it go, that would be a shift 3. Because normally where that 8 would be over here. This would go, except for my thing is right there. So 3 would be right there. And then 8 is also right there. So it basically shifted it back 3. So that one moves it left or right. So I'm going to come back here. So we had the plus 3 at the end moves it up or down. Plus 3 in the middle moves it left or right. And then those are always going to be opposites. If you're doing something that goes left or right, undo. I'm going to highlight that. It moves it left or right. They're going to be opposites. I'm going to highlight it so you can remember it's an opposite. Now let's take that same one and we're going to multiply 2 to the x, but we're going to do 3 multiplied by that. And it makes, instead of 0, 1, it starts up at 3. It just, it's a vertical. So what that thing would do if you multiplied it by the front, and then we do a 1/3 in, 1/3, is it's going to vertically shrink it or stretch it. Vertical, oops. Vertical stretch or compression, which is also called a shrink. And then last main one that we're talking about is if we did that just to the x. So 2 to the 3x. Notice it made it steeper, faster. So that is a horizontal stretch or compression. Wow, I wrote this down and it was very sloppy. Stretch. Or is that supposed to be CH, and then that's supposed to be a slash or compression. And then I wanted to show you if it was just a negative. So we have 2 to our x. If we put a negative there, it flips it across. Which axis was that? So a negative with the x made it reflect across the y-axis. While if we just put the negative on the 2, it reflects it across the y-axis. I mean the x-axis. I'm going to write this down. So we had horizontal stretch and compression. The negative on the x flipped it across the y-axis, and on the 2 across the x-axis. Really short version of like everything. What we're doing now from here on is going to be doing these examples. So if we had the function 2 multiplied by 3 to the x minus 4, and it was translated to become 2 multiplied by 3 to the x plus 5, what is the effect on f? And if you understood the lesson completely, you wouldn't have to graph it, but you are welcome to graph it. I wanted to show you that you could. So we had 2, I'm just going to clear these out. We had 2 multiplied by 3 to the x. Whoa. to the x, and then subtract 4. And I want to compare that. That is so funny that it does that thing at the end. And then I want to compare that to 2 multiplied by 3 to the x, and then plus 5. So what was different between those? They look like they have the same exact curve. The only difference was it moved it up 9, right? Because -4 and 5 is 9. So we would say it moved it up 9, moved f of x up 9. And then we have these two to compare. What is the difference? Like how it was translated from 25 times by 5 to the x subtract 2 to 5 to the x plus 5 subtract 2. So for doing that one, you have to remember rules of exponents that I think are kind of weird. And I like them. They're kind of, I call them trippy math because they don't follow what you would think would happen. If you multiply a to the x multiplied by a to the x, you would add the exponents. So you'd have x plus x, which would be 2x. Or if you had a to the x multiplied by a to the third, it would be a to the x plus 3. So if we're talking about this one right here, 25 is the same thing as 5 squared. And if we did 5 squared times multiplied by 5 to the x, that would actually be 5 to the x plus 2. And then how would we have to get, what would we have to do 5 to the x plus 5 minus 2? So let's go up to our rule. It's opposite. It's left or right. So if we add, that means we're going left, and it went 3 more. So this one moved it left 3 because it was 2, went to 5. And we had to add 3, which means left 3. All right, so we have that function is dilated to become that. What is the effect on f of x? So this is, again, where it's the opposite thing. If we had, and I didn't show you so much on this one because I was kind of rushing through it, but this right here would be a horizontal because it's on right next to the x. And it's going to be a horizontal, so a stretch would be this one, right? Because that one made it tighter. Okay, horizontal stretch. Oops, horizontal. Stretch by 1/2, because it was 1/2 right here. All right, this graph shows the pre-image of 2 to the x minus 1 becoming g to the x. What is the transformation rule? So it looks to me like this. So this red one was the f of x, and then it reflected across the y-axis. So let's go up here. Which one reflected across the y-axis? It's this one right here. So it reflected it across the y-axis. So the function rule was reflected across the y-axis. And then the function rule would be just g of x is equal to, and let's see, reflecting it across the y-axis means I need to put the negative with the x. To be equal to 2 to the negative x minus 1. Okay. And then the rest of them are comparing graphs. So I highly recommend using these things. So if I had 1/2 to the x, subtract 4, like this says. So 1/2, clear these out. 1/2, whoop, to the x, and then subtract 4. So there's the original one. And then you are supposed to compare that to the next one, which is take the original one, and we're supposed to add 5 to it. So we can even go like this. I'll just do 1/2. I did that the last time also. To the x, subtract 4, and it says, oops, subtract 4, and then it says I'm supposed to add 5 to that. So I'm just going to add 5, just straight up add 5. So then you'd find the graph. This is multiple choice. I would say, like, what's the function and what's its graph. So just make sure that all the points line up when you graph them both. So basically our drawing for this one was like, let's look at our graph again. So it was down, and this crossed at -3, and that crosses at 2. So on our graph here, we would see this crosses at -3, and that crosses at 2. So they both come down like this, or like that, something like that. So you'd find that one. Same thing with the next one. If you did 1/2 in front of it, so 5 to the x plus 1. So 5 to the x plus 1 compared to 1/2 of that. Let's make sure 1/2 of that whole thing. So 1/2 of 5 to the x plus 1. And I think I'm going to zoom in here so we can see better points. So that's at 2, and that's at 1. Okay, so then you would just graph those. And that's basically all you do for f.bf.3 for unit